Hey guys, today we're going to be solving one of the hardest ACT math problems. So first off, we have problem number 59. The ellipse x squared over plus y squared, x squared over 25 plus y squared over 16 is equal to 1 is shown in the standard xy coordinate plane below. The major axis is AD, the minor axis is BF. The foci are G and H. The points C and E are on the ellipse. Which of the following relationships is true? So now these problems are really hard, not really due to the complexity of the problem. It's really just due to understanding like what an ellipse is and all that type of stuff. So first off, I'm just gonna write the standard equation of an ellipse so you guys can understand, like where I got these values from. So it's very important that you know that A and B can be changed interchangeably. In this case, the major axis is AD, so it's saying that the bigger axis is the horizontal one. Sorry for my bad drawing, is the horizontal one, which is why I kept A underneath the X one and the B underneath the Y one, because B represents the minor axis and then A represents the major one. So that's really all you have to know about that. And then you have to understand the center. So center here is just 0, 0 because there's no transformation steps for X or Y. There's no really major transformation steps. So that's just why the center is 0, 0. And the very, confusing part is that it says the points C and E are on the ellipse. Sorry, not that part. The foci are G and H. So what are foci? What is that? Wow, how is it significant? That's, the most important part, like the most confusing part, I guess. So really what the foci is just the two, so in a circle, for example, I think it'd be easier. We have our center, right? We have our center. But in our ellipse, we don't actually have a set center. We have two foci, which basically, if I draw I know this doesn't really look that good. I draw like an ellipse around that, for example. Any point from here to here or here to here are always equidistant. So like they are for a circle. So they're not equidistant. If we keep a center right here, they're not equidistant from the circle due to the length of the arcs. So this arc is kind of bigger. AD arc is bigger than the BF arc. So it's very important to understand that the foci are basically your new centers. So we have our two new centers at H and G. And now it's asking which of the following relationships are true. So if you understand what the ellipse is, what the foci are, you know that any 2 points are equidistant, right? So we can technically say that G and C and G and E are the same distance. Sorry, I kind of did that wrong. C and G and C and H, because I need 2 points, is the same distance as EH and GE. We can say that they're both the, actually, let me make that a little bit brighter. You guys can see. So these are the same 2 points. They're basically both equidistant from G. C and G would be equal to E G plus E H. This is plus CH. Because remember, all these points are equidistant from each other. So the answer is just E. So really it's just confusing because you guys might not have learned of ellipses, but if you review it, it'll be pretty easy. All right, next question. For certain positive integers A and B, the greatest common divisors of A and B is 1. So the GCD. I'll get into what the GCD is and all that in a minute. So the GCD is equal to 1. And then 9A is equal to 4B if it can be determined which of the following statements must be true. So a quick tip here is that it's usually never K. It sometimes can be K, but they generally don't give K because most people guess K when they don't know what the answer is. So they usually just guess cannot be determined from the given information. Most people guess that, which is why I don't really recommend if you ever had to guess in a scenario, don't pick K. Actually, don't pick the one that says cannot be determined for the given information. You could pick K, but Like, don't pick those types of answer choices. Just a quick tip. But anyways, the greatest common divisor of A and B is 1, and 9A is equal to 4B. If it can be determined, which of the following statements must be true for A and B. Okay, so what is a GCD? That's what I'm going to start off with. A GCD is basically, you know how we have a GCF, right? That's our greatest common factor, and I'm sure you all know what that is because you guys probably passed Algebra 1. And that's basically like, let's say we have 9 and 3. The greatest common factor of both would be 3. So basically, it's whatever number we can divide both numbers by, like the greatest whole number integer we can divide both numbers by and still get a resulting integer. So if we divide both by 3, we get 3 and 1. So in this case, our greatest common divisor, which means if we divide any two numbers, let's say, I'm not going to use these examples. Let's say we use like 7 and 5, for example. There's no factors that we have in common here that we can actually divide with to get a whole number. So the greatest common divisor that we can divide both things by to get itself, because 7 divided by 1 is just 7, and 5 divided by 1 is just 5. So the GCD is just 1. It's basically just like kind of not a prime number, but it's just when two numbers don't have the same factors. So now that we got that out of the way, let's figure out. So the equation is 9A is equal to 4B. So I'm going to quickly transform that equation. So we have 9A is equal to 4B, right? And what I can actually do here is I can divide B from both sides. Sorry about this A. I can divide B from both sides. So we get 9A is equal to 4. And we can divide 9 by both sides. So we get 9A over B is equal to 4 over 9. So by theory, we can literally now just say that A is equal to 4 and then B is equal to 9. Some of you all might be saying, well, this could also be, you know, like 16 over like 36. Because if I multiply both of these by 4, we get 16 over 36. But at the end of the day, if you simplify this down, it always gives you a resulting value of 4 over 9. So we can assume from this equation that A is equal to 4 and then B is equal to 9. Now, does this satisfy our equation about the GCD being equal to 1? So let's see. So we have 4 and 9. Are there any two factors we can divide 4 and... Is there anything at all that we can divide both 4 and 9 by to get a resulting integer? Is there any two common factors? No, not really, because 4 is just like 2 times 2, and then 9 is like 3 times 3, and there's really no factor that you can divide both by to get a resulting whole integer. So really, that's not going to work, so it satisfies our equation that our GCD is 3. Let me clear up some space here. All right. So now it says, which of the following statements must be true for A and B? So we already really know. A is equal to 4, B is equal to 9. So we know this is 2 times 2. This is 3 times 3. That's just by, you know, multiplication. And we can literally just say it's F right here. Because, you know, 2 is a factor of A and then 3 is a factor of B. So, yeah, that's all really the problem is. All right, next one. This is really easy if you remember algebra 2. So it says for all angle measures A and greater than 0, which of the following expressions is equal to cosine of A? So basically, if you remember the unit circle, which is like this little circle right here, that's really annoying. We all had to memorize. And there's 4 quadrants here in this quadrant. You don't really have to know about the values and all that. Just you have to know that like tan, sine, and then cosine are all positive here. Here, cosine is negative. Tan is negative, sine is positive. Here, sine is positive, sine is negative, cosine is negative, tangent is positive. And then here, tangent is negative, cosine is positive, sine is still negative. Okay, so now we know that. So now it says, which of the following expressions could be equal to cosine A? Now I'm just going to pick a random, degree value in a unit circle. Remember, the circle has a total degrees of 360. And let's just say I pick like 30 degrees, for example. I'm just coming up with this. So the cosine of 30 degrees is equal to, well, that's pi over 3, and then that's equal to 1/2. How I got that value is you just have to memorize the unit circle. There's not really much I can tell you there. I mean, I guess you could also draw out a triangle, but it's really just, you just got to memorize the unit circle. So in the unit circle at 30 degrees, cosine is 1/2. So now that I know that, right, cosine, now we can do trial and error, literally. So 90 plus 30, and this is just cosine of 120, the first one. And cosine of 120 would be like somewhere over here. And then we know that cosine is negative here, first of all. So we can literally just mark that off already. Now we do 180 minus 30. Because cosine, technically 30 degrees is in the first quadrant. So cosine has to be positive. So we can literally just cross off every single value that's in one of these two quadrants, second and third quadrant. We're just looking for a value in the fourth quadrant. So now we have 180 minus 30. That doesn't work either. That's 150. 180 plus 30, that's 210. That doesn't work. 270 plus 30, that's 300. Okay, so if you remember your angle measure, that's 9, that's 90, that's 180. This is also like 362. I guess let me actually draw it over here so you guys can see it better. Sorry if my handwriting looks a little bit messy. So we can eliminate all three of those immediately off the bat. Now we're left with J, cosine of 270 plus A, and then 360 minus A. So if you don't really remember unit circle values, you could guess here because we know that one of these is 300 and another one is 330. But you don't actually need to guess because what you have to remember is the cosine here is 1/2, right? And it's a positive 1/2. So we're just trying to look in the other quadrant, fourth quadrant, and see where the cosine also has a positive 1/2, and that value is the cosine of 300. You just have to remember your unit circle, and this problem becomes very easy. All right, next problem. Sorry, it already has some of the answers. So really, I'm just going to explain this problem. I guess I already wrote it down. So it says, in the equation ax squared plus bx is equal to c, coefficients a and b, a, b, and c are positive real numbers. If a equals c and both roots of the quadratic equation are real numbers, which the following relationships must hold between a and b. So this is really a discriminant formula, because the minute they say roots and you're not given any real values, just always think discriminant formula, which is b squared minus 4ac is greater than 0. B squared minus 4ac is equal to 0. And then b squared minus 4ac is less than 0. Basically means this is imaginary roots. But I suggest you watch a YouTube video on it if you don't know this, because this is very important. You have to know this. For SAT or ACT, right now I'm doing ACT problems, but I'll be doing SAT problems in the future. This one means there's one real solution. But we know it's not these two because it literally says here that A and C are both roots. So we would have to go with this formula right here. This would be our formula. So that's why I have that formula all the way down here. And we have, our equal to sign, because A and C are both, they're equal to each other. So technically they would have the same root. So technically, in technical terms, they are the same root. So we're just going to say greater than or equal to in this case. And also because some of the values have greater than or equal to. And we'll get into that later. All right, so first thing, you know that A is equal to C. So we can literally just substitute in C for A because, we can just do that. I don't think there's much explaining to do there. So b squared minus 4a times a is greater than 0, greater than or equal to 0. Then b squared minus 4a is, because I just multiply the a's together, is greater than or equal to 0. And then you have a squared. So what I did here, this is a little bit confusing of what I did here. Let me try to redo what I did there. So b squared minus 4a squared is greater than or equal to 0, right? And then now, sorry about that. So now we do b squared 4a squared is greater than or equal to 0. So now what I just did was I just want to get a by itself, really. So I subtracted b squared over to both sides, which gives me negative b squared over here. And now I divided both sides by negative 4, which we have to flip the sign. Remember, we have to flip the sign when it's negative. So it gets me b squared over 4. So a squared is less than or equal to b squared over 4. Now I can square root both sides. And then if you square root b squared over 4, you just get a is less than or equal to b over 2. And that's just k. All right, hopefully that problem was simple. All right, and then on to our last problem of the day. All right, so in this problem, it says in the standard xy coordinate plane below, point A has a coordinates 2, -4, and point B has a 8, -1, divides AC so that the ratio between A and B and C is 1 to 3. What are the coordinates of point C? So point C is right over here. It's an imaginary point. You cannot actually see it. But anyways, so what are the coordinates of it? So what I can actually do here, I know I kind of already solved it out, but what you have to really understand here is I don't want you guys to look at any of this stuff right here. I don't want you guys to look at any of this stuff right here. It's not that important, all of this stuff, because of, it's just not that important. So we're just going to clear it out, with some white out. All right, so anyways, the main thing I want to focus on right here is this point, is that we're not given C, right? So some of you guys might be confused because like, oh wait, I'm not given C, so now how am I supposed to solve this, right? I'm not given C. There's no way I can solve this problem because I don't know where C is located. But what I do know is that for the ratio between A and B and C is 1 to 3. So it could be very well true that C is somewhere over here. But for the purposes of it being a straight line, I just want to keep C, somewhere up here so that it's a straight line. Yeah, it's an ugly looking C, but it's a C nonetheless. So, so for the purpose of doing that, that's what we're going to do. So anyways, coming back. Now that we have that C is over here, we want to figure out what are the coordinates of point C, obviously. That's the main thing. So we know the ratio from A to B to C is 1 to 3. So what we can actually do here is literally just know that, 8 to 2. How much is 8 to 2, right? Like how much should we go up by to get it to 8? We added 6, right, to get this equal to 8 for the x-coordinate. And for the y-coordinate, we went from -4, and then we added 3 to that, and then we got -1. So that's how we got that 0.8 comma -1. That's how we got it. So we know that basically he just added x. He added 6x here, and then he added 3y. 3 to the y and then 6 to the x. So knowing that, we can literally just multiply this ratio by 3. So we added 6, right? And it says the ratio is 1 to 3. So if this is 1, if 6x is 1, then if we multiply that by 3, we get that ratio. So this is 18x. And then for y, we multiply that also by 3, we get 9y. So from the point 8 comma -1, you add 18x, which gives you 26, and then you add 9y, which -1 plus 9 is equal to 8. So that's how you get the answer of D. Hope you guys enjoyed this video. If you guys want to see more videos, please make sure to like and subscribe. Thank you so much.